In today's video, we will be talking about working power and mainly how to solve those problems involving working power. Work is defined as the transfer of energy to a body by an application of some force that is moved across some distance. The really important thing to know here is in physics, the definition of work, you have to go over some distance. So for example, if I am pushing against a wall of a building, even though I'm applying force, I'm not technically doing any work because the wall isn't moving. So we have to have some type of movement in order to have us fit the physical description of work. The SI unit is going to be a joule. A joule is equal to a Newton times a meter, which is the same thing as kilogram times meter squared divided by second squared. Let's go ahead and jump into our first problem. Again, work is going to equal force times distance, where the unit for force is newtons and the unit for distance is meters, and our overall unit for work is going to be joules. So a crane uses an average force of 5,200 newtons to lift a steel beam of 25 meters. How much work does the crane actually do? So let's see what we're given here. First, we're given 5,200 newtons. Newton's going to be a force. Then we're given a distance of 25 meters. Again, always ask yourself, are these the correct units to solve the problem? And in this case, we are. We're both in newtons and in meters. So for here, we can just plug in the force times the distance. So that'd be 5,200 newtons times 25 meters, which is going to give us 130,000 joules. In our second work problem, a bicycle brakes apply 142 newtons of frictional force to the wheels as the bike slows down. The brakes do 1.85 kilojoules worth of work. Over how much distance does the bike slow down? So here we're asking for distance. So in first we're given work. So work equals 1.85 kilojoules. And we are also giving 142 newtons, which is the force. So we'll be solving for distance. Again, the first thing I always want to ask myself, is this the correct unit? And in this case, it's not. Here we're given kilojoules. We don't need to be in kilojoules. We need to be in joules. So we need to convert 1.85 kilojoules into joules. So there's 1,000 joules for every 1 kilojoule. So that's going to make it 1,850 joules. So that's what we need to use for this formula. So now we have everything in the correct units. Work equals force times distance. We need to get distance on a side by itself. So we're going to divide both sides by force. So this gives us distance equals work divided by force. So the work is 1,850 joules divided by 142 newtons. This is going to give us a distance of 13.02 meters. For our last work problem, a hydraulic lift raises a car 1,200 kilograms 50 meters off the ground. How much work does the lift do on the car? So again, here we're going to be solving for work, and it gives us a force and a distance. Those are the two variables that we have to figure out. Now, it gives us a distance of 50 meters, so we can plug that in for distance. However, force, it doesn't really give us a force. It says 1,200 kilograms. Well, 1,200 kilograms, that's a mass. So currently we're working with, well, we need to know force to solve this problem. You need to ask yourself, how does mass and force relate to each other? Well, in terms of how they relate to each other, is force is equal to mass times gravity. Let me make sure I spell gravity correctly. Gravity. So force equals mass times gravity. So gravity, of course, on Earth is 9.8 meters per second squared. We're going to need to know our mass in kilograms. So to solve this, or to plug in for force, we can say force equals our mass, which is 1,200 kilograms, times our gravity, which is 9.8 meters per second squared. And this is going to give us 11,760 newtons. Because remember, 1 newton just equals kilogram times meter per second squared. So now we're going to plug this number, 11,760 newtons, in for the force, and we now have everything to solve this problem. So work equals force times distance. That's 11,760 newtons times 50 meters. And a newton meter is, of course, going to equal a joule. So 588,000 joules is going to be the work that it takes here to lift this car off the ground. Switching gears just slightly, now we're going to be discussing power. So power is any quantity that measures the rate at which work is done or how energy is transformed. So our power equation is power equals work over time. We've just defined what work was, where work equals force times distance, and that comes out to be a joule. And in this case, we're going to be using seconds to measure time. And a joule divided by a second equals 1 watt. For our first power example, it says lifting an elevator 18 meters takes 100 kilojoules. If doing so takes 20 seconds, what is the average power of the elevator during this process? So remember, power equals work divided by time. And let's remember our units here. So power is measured in watts, which is a capital W. Work is going to be measured in joules, and time is measured in seconds. So if we take a look at the information that's giving us, we know we want to calculate the average power. And to do that, we need both work and time. So for the work is measured in joules. Well, it tells us that it takes 100 kilojoules. So 100 kilojoules. In terms of time, it says it takes 20 seconds. Now, it also gives us this 18 meters right here, but we really don't need that information to solve this problem. So that's just extra information it's giving you. But currently, we have all the information that we need. The only thing that we need to do is we need to convert this kilojoules into joules, because joules is the appropriate unit to solve this problem. So 100 kilojoules. There's 1,000 joules in 1 kilojoule. So that is going to become 100,000 joules. And so that is the number that we will use, is 100,000 joules. So power equals work divided by time. Our work is going to be 100,000 joules divided by 20 seconds, which is going to give us 5,000 watts. Now, one thing you need to make sure not to kind of confuse here is we're kind of working with two different capital W's. We have this capital W right here, which is a unit for watts, and we're also working with the capital W in the formula. So sometimes we just abbreviate this formula. Power equals W over T. In this case, this capital W is going to be work. So make sure you're not confusing units for work or watts for work. Make sure you can keep up with the difference between those. And for our last power example today, it says Sandy walks up the stairs on her way to class. She has a mass of 75 kilograms. Altogether, the stairs go up 4.8 meters vertically. If she climbs the stairs in 12.6 seconds, what is her power output? So it's asking for us to solve power. Power equals work divided by time. So we're trying to solve for power. In order to solve for power, we need to know work and we need to know time. So let's see what information this problem gives us. It says it takes her 12.6 seconds to climb up these stairs. And so now for work, remember the unit for work is joules. We're not given any information in joules. We're given kilograms and we're given meters. So kilograms is going to be a form of mass. So mass equals 75 kilograms. And we're also giving a distance of 4.8 meters. So how do mass and distance relate to work? That's the question that we need to answer. Well, in terms of distance, I know another way that I can solve for work is that work equals force times distance. So here, our distance is going to be 4.8 meters. So work, force, and distance. Distance is 4.8 meters. So I've used this information. Now it gives me 75 kilograms. How can I use kilograms in terms of force? That's just going to be just like one of our previous examples, where we can take force, which equals mass times acceleration. That's from our Newton's second law, force equals mass times acceleration. In this case, the acceleration is gravity. Gravity is what's pulling us down. So 75 kilograms times gravity, which is 9.8 meters per second squared. So in this case, our force is going to be 735 newtons. So I can plug that number back in here. Now I know force and distance, so I can solve this work problem, or I can solve the problem and obtain the work value. So work equals 735 newtons times 4.8 meters. Our work value is going to be 3,528 joules. And then this number gets plugged back into our original problem, because remember, although we've solved for force and we've solved for work, it seems like we've done a lot of work, but we still haven't answered what the question is asking, and that's for power. So this 3,528 joules goes in for the value of work. Now we can finally solve for power. Power equals work divided by time. This is going to be 3,528 joules divided by 12.6 seconds. And so our answer for power is 280 joules per second, or 280 watts.